Welcome to another video from explainingcomputers.com. This time I'm going to show you how to wire Ethernet extensions. By this I mean both making up patch leads like this, as well as fitting new Ethernet sockets. So let's go and get started. When wiring an Ethernet extension, it's really important to select the right cable. All decent cables will have their specification printed on them, as we can see here with these cables that I'm about to use in my own project. Specifically, I bought this cable to make a 20-metre permanent extension to my garage or garage, depending how you want to pronounce it. There's about 50 metres of cable here. I only need about 20 at least for this project. And I've also found in my box of supplies this cable, which I'm going to use to make some Ethernet patch leads to connect computers to Ethernet sockets. So let's run through how we select the right cable. Firstly, we need to choose the right category, or CAT. Network cables on the market today range from Cat5 to Cat8, and the higher the category, the faster the data transfer speed the cable can support. As we can see, Cat5 cable is limited to 100 megabits per second, and as most Ethernet devices today support a speed of 1000 megabits or 1 gigabit, Cat5 should generally be avoided unless you're absolutely certain you only need 100 megabit connection. Meanwhile, Cat5e or Category 5 Enhanced does support 1 gigabit speeds and is therefore an acceptable choice for many patch cables. This said, when installing permanent cabling, the minimum choice today should be Cat6 or above to allow for future equipment upgrades. Here, the cable I'm using for my garage extension is Cat6, which will support up to 10 gigabits across the 20 metre length I'm going to fit, although right now all of my equipment is 1 gigabit and my internet connection about 50 megabits, so this cable is very well specified for the task in hand. Meanwhile, my patch lead cable is Cat7, although not of the same connection quality in other respects as we're about to see. Beyond the category ranking, a second important consideration is whether a cable is solid or stranded core. In an Ethernet cable, data is carried in 8 wires which are arranged in 4 twisted pairs. As we can see, in solid core cable, each wire in each twisted pair is a single cylinder of metal, whereas in stranded core cable, each wire consists of several strands. Generally, solid core cables act as better conductors and have better electrical characteristics, and so are the best choice for long cable runs and permanent installations. And so, the cable here for my garage extension, this is a solid core cable. On the other hand, stranded core cables like this one are more flexible, they've got a smaller bending radius, which makes them a better choice for making up the patch cables that link computers to network sockets. The third thing to be aware of is that the wires in different Ethernet cables come with different wire thicknesses, which typically range from 23 to 28 AWG or American wire gauge, with the smaller number indicating a thicker wire. So, when wiring permanent extensions, go for the smallest AWG value you can, with this being particularly important if you want to run power as well as data down your cable using PoE or Power over Ethernet. However, if you want to make up the most flexible short patch leads, use a high AWG value cable. And so here, my stranded core cable for my patch leads, this is AWG28, quite a thin wire, but my solid core cable is AWG24. It's got much thicker wires inside the cable. A fourth thing to be aware of, there are even more things to consider when picking a cable, is that not all cables have their wires made from the same conductors, with common choices being solid copper, copper-clad aluminium, known as CCA, or copper-clad steel, known as CCS. Here, solid copper offers the best connectivity, but is more expensive. But once again, when fitting a permanent cable, go for solid copper if possible, and so here this cable is solid copper and declares itself as such. In contrast, this cable over here, my patch cable, doesn't tell us what it's made of, nothing printed on the sleeve to indicate what the conductor is. I would guess it is probably CCA, copper-clad aluminium. A fifth thing to consider when choosing cables is whether or not the wires inside the cable are shielded to avoid interference from other electrical items. Cat5 cable is never shielded, while Cat6a and above always are. Meanwhile, Cat6 is sometimes shielded and sometimes not. As this table indicates, shielding comes in many different varieties that indicate whether the whole cable is shielded and/or its inner twisted pairs. In general, the more shielding the better, although in most domestic situations shielding is not that critical unless you know that your cable will run near mains electrical items, such as say washing machines or generators, that are likely to produce electrical interference. Here my Cat7 cable is SFFTP with an outer braided shield and an outer foil, as well as shielded twisted pairs. But my Cat6 cable is not shielded, and I'm not worried about this, as this cable will mainly run outside, nowhere near anything else electrical. Talking of outside, a sixth and final consideration is whether you need a cable for internal or external use. Here my patch lead cable is internal, as you may suspect, but my garage extension cable, this is not just rated for external use, it's rated for direct burial. And for this purpose it has two separate plastic covers, the outer one made from HDPE and the inner from PVC, so it'll hopefully be well protected in the ground. And so there we are, and I bet you never thought there were so many things I could tell you about network cable. But if you are fitting a permanent Ethernet connection in particular, it's critical to get the cable right. And I hope that for me, this Cat6 solid core, solid copper AWG24 direct burial cable will prove a good long-term choice. In people's homes, Ethernet cables are most commonly terminated in an RJ45 plug or a wall socket. As we can see, a wall socket is a modular unit, and this clips into the type of wall plate you use in your country. This is a UK wall plate. We can clip it in here like this. There we are, and this gives us an RJ45 socket, as you can see down in there, but also there's a little nameplate here which I've already labelled for my project. And after this is wired up, it gets screwed into a pattress or fitting box, either a metal box like this, which is mounted directly in the wall, or you might use a surface mounted box like this. Transitioning across to the things we put into sockets, RJ45 plugs come in various types, for example shielded or non-shielded as we've got here, and they can either be one-piece plugs like these, or they can be multi-piece, and they normally come with some sort of a protective sleeve which goes on the back of the plug, as you can see here. Plugs like this can also be pass-through or non-pass-through, and here we have one of each. The difference is that pass-through plugs have holes in the end through which the wires will pass when they're being connected before being cut off, as we'll shortly see. To wire up both plugs and sockets, some tools are needed, and as a minimum, to wire a socket you'll need a punch down tool like this, which also serves as a wire stripper. Meanwhile, to connect plugs you will need a crimping tool, something like this, a very exciting device. Various types are available, and most crimpers also offer wire cutting and wire stripping functionality. And if you're going to use pass-through plugs, your life will be so much easier if you get a crimping tool like this one, which has got a special blade down here, which is designed to cut off the pass-through cables to trim them off neatly when you're crimping the plug. Many other tools are also available, often in kits with a crimping tool, but a final one I'd point out that can be very useful to have is one of these. This is a cable tester where you can plug your cables in the top just to check you've wired things up correctly. Right, let's now wire up our socket, and I'm going to do this as a demonstration with it securely fastened down to my workbench to make things easier to film. Here I'm working with our solid core cable. I'm going to bring in my crimping tool just initially to cut off the end to make it nice and neat like that's a nice neat end. I only produced that bit like that to show you different wires earlier on. And we now need to strip off a couple of inches of the outer protection here. So I'm going to put it into the right place in the crimping tool. You could use another wire stripping tool. I'm going to use my crimping tool. I now need to go down 9 clicks on this, I think. That should be the right number. And now we just have to rotate around. We'll do a couple of rotations like that, maybe 3 for good measure. There we are. And hopefully, if that is correct, yes, that will take off the outer protection, the 2 layers of outer protection on this particular cable, and that's ready to use. And it's always a very good idea at this point in time to really inspect the cable carefully, just to check you've not cut the twisted pairs. And everything here seems to be okay, so I'm just going to separate the cables out a little bit, because there's a central divider in this cable, as you can see, central piece of plastic that has to go. So we'll just get these out of our way, bring in a little pair of nail scissors and carefully just get that cut out. There we are, like that. And we're now ready to go back to the socket, where we need to decide how to wire it up. And I say decide as there are 2 termination standards in use, known as T568A and T568B. These are set by the Telecommunications Industry Association, or TIA, and you can use either one, providing that you're consistent and use the same standard at each end when wiring an extension socket or patch cable. Many sources suggest that T568A is preferred, but that T568B is more common, and here we'll be using T568B because there's a label for it in our socket. So I'm going to bring in our cable. I've just realised I haven't cut off this piece of a cord, so we'll get rid of that like that. And then we're going to secure the cable down here using a cable tie. So I'll get on with that. There we are. Hopefully that will be okay. And we now need to wire the wires down into the connectors here. And they push into place. We don't need to strip off the insulation. It'll come off itself automatically. And you'll see each twisted pair has got a solid wire and also a striped wire. So we've got here the striped orange and the solid orange. And the orange is the one we're going to start with. So we'll take solid orange, which goes down here according to this wiring standard. We just push it down in like that. And then we take our punch down tool and we punch it down. I guess that's where the word comes from, isn't it? Not a difficult word to use. There we are. And that is nicely in the connector. So I will get on with the others. And there we are. All the wires are now properly in place. So I'll just remove the excess. And there we are. This last little piece doesn't want to go away. But there we are. We have now got a fully wired Ethernet socket. And it would be a good idea to test this, but we can't test it until we've got something terminating the other end of the cable. So we'll come back to this later in the video when the socket is in its final location. Guess what? I'm now going to wire up a patch lead, an Ethernet cable with a plug at each end, using about 1 metre of our Cat7 cable. And I'm going to start by taking the protective sleeves for the plugs and putting those on the end of the wire and forcing it down there, because if you don't do this early on, you forget to do it and then you get mad at the end because you've got to cut everything off to start again. So with that done, let's take the crimping tool, and again I need to strip off a couple of inches of wire on the end of the cable, take off the protective cover, the outer coating, and here I think it's 11 clicks. Like that, hopefully. This is much easier cable to work with. It's only got a single outer, and there we are. That came off very easily indeed. But as you can see here, this cable is shielded, so we need to remove the shielding. And basically what we need to do is take the braid, push it down there, like that. There's an awful lot to deal with here. I normally take the braid and just wind it around a little bit initially, get that out the way. But then we also need to deal with the foil, and I think I'm going to take that off with some scissors again. Obviously we don't want to cut any wires, we need to get rid of, that's the outer foil. And then we've now got our twisted pairs, which are also foiled, so I also need to remove the foil from them as well. And there we are, I think we can work with that. And then we now need to take the individual twisted pairs and to separate them out and to put them in the right order. And again, we're going to be using the standard T568B, B, which requires us to have these in a line which is going to be orange stripe orange, green stripe blue, blue stripe green, brown stripe brown. And there we are. I think I've now got the wires roughly flattened out in the right order. It's a fiddly thing to do. And if we go down to our plug, which I've fastened to the corner of this box, so I've got a hope of showing you this on camera in focus, I'm going to take our wires and feed them in, hopefully accurately like that, and they should go in and pop out through the end, and we should see they're still the right order. Orange stripe orange, green stripe blue, blue stripe green, brown stripe brown, they are. So we can keep feeding them through our pass-through connector. Pass-through connectors are wonderful things like that. We can feed that through like that, and then we can take our plug and go across to our crimper, where all we need to do in theory is to pass the wires through like that. We need to come out to the side, there they have, and the plug sits nicely in the crimper like that, make sure it's absolutely in place, and all we need to do now is to push down on the crimper, nice and tight, like that. You can see on that side all the wires have been cut off, and in theory we can release it, and yes, we've crimped a plug onto the end of our cable, and we can just put into place the little plastic thing there like that, and there we are. That is a pretty good result. We've got an Ethernet cable with a plug on the end. And by the magic of filmmaking, our cable has now got a connector at both ends. So let's bring in our cable tester, and we just have to plug the cable into the sockets on the end of here. Plug one in there and the other one in here. There we are, it's all set up. So we can now go to the cable tester and, moment of truth, turn it on like that, and you will see the lights go down in sequence, and they are in the correct order. So that's very good news indeed. That means everything is connected up correctly. And that's going at normal speed. It can go at slow speed as well if we want to check at a slower speed. And so there we are. We've made up a patch cable. I've also shown you how to wire a socket. So I think it's now time to show you my actual project and how it's being implemented. Greetings and welcome to a wall that's normally hidden behind an equipment rack at the side of my desk. But right now both of those are moved out of the way, and a wall that didn't have an Ethernet socket now has an Ethernet socket. To fit this, I went outside with a very long drill and drilled in through the wall. And note, when you do this, you should have your drill pointing slightly upwards to avoid water ingress. But sadly, I didn't do that. I thought I did, but clearly I didn't. But my final hole is very neat, and I will seal it with silicone. And certainly, my final hole is much neater than the one drilled by the professional telecoms engineer just below it, where they split the brick entirely. And I avoided doing this by drilling from the outside in rather than the inside out. This said, on the inside I did have some plaster come off, and indeed I lost more of the skin when I cut the hole for the wall box, but the box went in with no problems, screwed firmly into place, and then I just used a bit of plaster and a bit of paint to tidy things up. You might notice here I've got the cable coming through on one side at the base of the box. That was my intention, because it is quite difficult to bend the cable. It's got a very small bending radius, and that gave me the maximum chance of wiring things up okay. But as you can see, wired things up I did, and as you can see, it's now nicely in place. I'm very pleased with the final result. So let's take our patch cable and plug it in to the socket, if I can do it like that. There we are, that's plugged in. And I'm going to plug the other end of this cable into our cable tester, which I've got here. We'll plug that in like that. And here I've put a plug on the end of the cable which is going out to the garage, the one wired to the socket I've just put into the wall. I've just put a temporary connector on the end of this. Rather difficult to do with a cable this inflexible, but hopefully that will go in the top and click in like that. It has, and therefore the moment of truth, if we turn this on, yes, I seem to have got it right. Everything's wired correctly in the wall and on the temporary plug. Cable hasn't been damaged. That's working fine. But I also want to do a final test, which is to turn this off and to take this connector and to plug it in to the back of my router. There we are. And I'm now going to go out to the garage, taking with me the cable now looped through the garage door. It's not under the ground yet, and it's plugged into this Ethernet to USB 3 adapter and into my Surface tablet, where I'm going to run a speed test. And this is of course what it's all about, having a working internet connection out in my garage. It should be about 45 megabits download, about 9 uploads, something like that. Let's see what happens. It's looking okay. Of course it varies across time. You never know exactly what you're going to get, but it looks pretty good. It seems to be working. Clearly the basis is working. We've got an internet connection here through that Ethernet cable, no problems at all. Slightly slow, and I hope not too bad actually. What's it doing? Oh no, it's going to be about what I anticipated. And if you're wondering, you're not going to see the other end of the cable terminated in this video, because I've got an electrician coming in to do all sorts of first fit electrics for my garage project in about a week's time, and he's going to take the Ethernet cable underground and bring it through into here, and I'll wire it in when that is finished. And of course I'll show you that when I do my mid-year review video, which will be coming up fairly soon. Recently, I was talking to a telecoms engineer who told me that the most common reason they're called out to a customer's home is because they've reported a slow broadband connection. And I asked him how often do they actually have a slow broadband connection, and he said not that often. He said most of the time he went into someone's home, connected an Ethernet lead to their router, their router, connected it to a test device or a laptop, and the broadband speed was fine. And the problem was the speed of the customer's Wi-Fi between their router and their devices. And I mention this because so many people could get such a better internet experience, better streaming of video, things like that, by using a wired connection between their router and their computers rather than Wi-Fi. And I hope in that context you've found this video useful. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.